Hello and welcome to Video Podcast 4.3. The previous two podcasts were focused on glaciers and their incredible landscaping power. In Video Podcast 4.3, we will turn our attention to deserts and arid landscapes. When we take a look at all of Earth's land surface, about 30% is arid. And when we talk about arid landscapes, we're talking primarily about deserts. Deserts are affected by many geological processes. For instance, mountain building, water erosion, and even wind erosion. So it's important that we know that deserts are not geologically dead, and the rock cycle is alive and well in these regions. Deserts tend to be concentrated in the subtropics and the mid-latitudes, and on the next slide we will talk about the specific reasons why. Now, technically speaking, deserts are classified as arid, but we also need to know that there are semi-arid regions known as steppe. And steppe climates are kind of the intermediates between desert and the more moisture-rich climates that we're more familiar with here in the Midwest. So what causes deserts? Earth's major deserts are caused by prevailing winds, and I'd like to highlight two specific convection cells shown in the image on the right. These convection cells illustrate the circular motion of air and energy in our atmosphere. And if we focus on the 30-degree latitude and work our way to the equator, you'll notice that the northeast and the southeast trade winds tend to bring air from the 30-degree latitude to the equator. When that air reaches the equator, there's an equatorial low pressure zone. And that warm air, which typically contains a lot of moisture, will rise once it reaches the equator. When that air rises, the large amount of moisture will condensate, forming clouds, and you'll see a lot of rainfall in the regions at or near the equator. That's also a reason why most of Earth's tropical rainforests tend to occur near the equator. But watch what happens to the air in that convection cell once all the moisture has fallen out as rain near the equator. The air that's returning poleward towards the 30-degree latitude is very dry, and that dry air will descend and warm, and basically blanket the 30-degree latitude in warm, hot air. When looking at the image of world desert distribution, you may have noticed that not all deserts occur at or near the 30-degree latitude. Some deserts can occur at the mid-latitudes. These mid-latitude deserts are the result of being located deep to the inside of very large land masses. Let's go back and look at that image once more. Let's focus in on Central Asia. You notice quite a bit of arid and semi-arid climate in this region. And this region is quite a bit higher than the 30-degree latitude. The reason there's such a prevalence of arid and semi-arid climates in this region is because it's very largely landlocked. Keep in mind that a great deal of atmospheric moisture originates from the ocean. And in regions where there's not an ocean or a large body of water nearby, the prevailing winds will not be able to bring a lot of moisture to these regions. Another factor that contributes to these climates shown is the Himalayan mountains. You might think that there will be a lot of moisture coming off of the Indian Ocean that could bring precipitation to Central Asia, but the Himalayan mountains act as a barrier. And at this point, I'd like to turn my attention to what we call rainshadow deserts. So what is a rainshadow desert? By definition, rainshadow deserts will form in places where mountain ranges act as barriers to the movement of water vapor. My previous discussion focused on Central Asia, but let's return to the United States for this particular example. In the image shown from left to right, we have the Pacific Ocean, we have California, and then we have the Sierra Nevada mountain range. And on the other side of the Sierra Nevada mountains, we have the Great Basin Desert. The prevailing winds will come off the Pacific Ocean and they will bring moisture. However, that moisture has a very hard time getting to the Great Basin Desert because as the prevailing winds work their way up the Sierra Nevada mountains, the water vapor in that moist air will condense, and you'll tend to find a lot more rain on the windward side of this mountain range. The opposite side of the mountain range is known as the leeward side, and by the time the air works its way over the mountains, it tends to be very dry because a lot of the moisture had already fallen out as precipitation on the windward side. So our very own Great Basin Desert is a rainshadow desert. Let's talk about some features of desert landscapes. Ephemeral streams are responsible for most of the erosion in desert regions, and that's a very important note to make. While wind erosion really isn't a factor anywhere but deserts, water erosion is still the primary means of erosion in these regions. Now, most of the time, these ephemeral streams will be dry because deserts don't tend to get very much rain. But when it does rain, and knowing that deserts tend to not have very good drainage, these ephemeral stream channels will fill up quite rapidly during heavy rainfalls, and they can transport large amounts of sediment and cause significant erosion. One last note I'd like to make is that due to the relatively poor drainage in desert regions, flash flooding is a very real concern. The last consideration in this podcast is the evolution of a desert landscape. On the previous slide, we talked about ephemeral streams, and on occasion deserts will experience very heavy rainfalls. The majority of erosion in deserts will occur during these very heavy rains. In the early stages of desert landscape development, we see some playa lakes, and a playa lake forms when rainfall is sufficient to cover the basin floor. But because deserts don't get rainfall very often, these playa lakes will often dry up. When they dry up, you can see the formation of salt flats, or rock salt, as I showed you in a previous vodcast. Another feature to note in the early stages of desert formation are alluvial fans. Alluvial fans look kind of like cone-shaped deposits, and you tend to find these alluvial fans at the mouth of a canyon. Let's turn our attention to the middle stages of desert landscape formation. We should first notice that the playa lakes had dried up, and now they're called playa. But the feature I'd like to focus on in middle stage desert landscape evolution is bajada. In the early stage image, we talked about alluvial fans. But what helps us identify the middle stage of desert landscape evolution is the presence of bajadas. Because if those alluvial fans, those cone-shaped sediment deposits, grow large enough, they will start to merge with their neighboring alluvial fans. And if you look closely at this image, you'll see that with bajada, the alluvial fans are all intersecting now. And then lastly, for the late stages of desert landscape evolution, the primary feature you see listed is the Inselberg. And Inselbergs are essentially just little knobs of bedrock. They're kind of the remnants of the mountain range that existed long ago. But for the sake of our conceptual understanding, I think there are 3 key features you have to know that will help you identify what stages of desert landscape evolution you're seeing. In the early stage, we'll see alluvial fans. In the middle stage, those alluvial fans will start to merge with one another to form bajada. And then in the late stages of desert landscape evolution, you'll see the Inselbergs. Okay, that concludes this video podcast. Our 4th video podcast will build on some of the concepts and information contained in this particular podcast. But it's important to keep in mind that even in desert regions, it's water erosion that's predominant. So just as a quick big picture summary, water and glaciers are the 2 most important erosional agents that we've considered. And wind erosion is a relatively minor concern compared to those 2. Okay, I will see you in Vodcast 4.4.